Students, बात शुरू करेंगे about our second multiplexing technique, which is the wavelength division multiplexing. Students, WDM या फिर wavelength division multiplexing was created to utilize the high data rate and the high bandwidth of an optical fiber cable. Students, जो fiber है, that offers higher data rates as compared to our metallic transmission medium. We still need to go through the details of this transmission medium in the further discussions, but for now you need to know that our copper wire, of course, has got a lower data rate as compared to the optical fiber system, which can carry signals in the form of light. Now, students, using a fiber optic cable, because it contains a large amount of bandwidth, it's got a high bandwidth capacity. If we carry a smaller number of links, if we carry one single link onto that optical fiber cable, we are essentially wasting all the bandwidth that this optical fiber has to offer. So students, what we do is we use the process of multiplexing, and the process of multiplexing using this optical fiber cable is called wavelength division multiplexing. Students, as you can see on the slide, we have got different components that are called lambda. So you've got lambda 1, lambda 2, and lambda 3. And conceptually, this is the same process as the frequency division multiplexing. And the only difference per se is that the multiplexing and demultiplexing, the process out here, it involves optical signals. So these are essentially light signals. And the reason for that is our transmission medium is fiber optic cable, and we need fiber optic channels to be transmitting over this fiber optic cable. Idea is exactly the same that we had for FDM. We are combining different signals of different frequencies. The difference is that the frequency in this particular case is very high because we are carrying signals in the form of light. So students, very narrow bands of light from different sources, lambda 1, lambda 2, and lambda 3. They are, let me complete this, different sources. They are combined to make a wider band of light, which is then transmitted over the fiber optic cable that we have. Students, at the receiving end, the signals are separated by a demultiplexer, and we get our narrow bands of light back. Now, students, I'm pretty sure from basic physics you understand the concept of a prism. This multiplexer, in the case of wavelength division multiplexing, is nothing but a set of prisms that we use, at both the multiplexing end and the demultiplexing end. Students, we want to combine multiple light sources into one single light source at the multiplexer, and we want to do the exact opposite at the demux or the demultiplexer. Now, students, in this particular case, this combining and splitting, as I said earlier, is easily handled by using a prism. And using this technique, the multiplexer side prism, it can combine several beams of light into one wide band beam of light that can travel over our fiber optic cable. And on the multiplexing side, our demux or our receiving prism can reverse this process to get our narrowband signals of light back. Students, one application of this is a network called as SONET. And we will go through this SONET in further discussions in detail. Students, there is another process that I want to talk about before I leave this. That is called DWDM, where the first D stands for dense wavelength division multiplexing. Students, the difference between WDM and DWDM is that in DWDM, we can multiplex a very large number of channels by spacing these channels very close together to get higher efficiency. So your DWDM is essentially more efficient than your wavelength division multiplexing the base process.